So far, we've seen that transactions allow users to enter, modify, and delete data in the tables of the application's database. Apart from this possibility of updating the database, sometimes we need to define an automatic update process. For example, the travel agency could need to increase prices every now and then of all recorded flights by applying a specific percentage to increase current prices. Using the transaction screen to manually edit every price for the hundreds of flights recorded would be an endless task, so we need a massive process to do it. To solve the example proposed, the first thing we'll do is add to the flight transaction an attribute for storing the price of each flight. We create the flight price attribute and define a domain called price as a numeric of 10. We save and press F5. GeneXus tells us that it'll add this field in the flight table. We proceed, and the programs are generated. Let's enter some prices for the flights we had recorded. Now we will see how to solve the requirement for increasing prices automatically and as a group. First, we need to ask the user the increase percentage to be applied to flight prices. To do so, we'll create an object of web panel type. We select New, Object, Web Panel, and name it Enter Percentage. The web panel object is basically a web page that allows us to solve different functionalities, like requesting data from the user, or providing queries which are functionally quite complete. If we include variables in a web panel's form, they will have data entry behavior, meaning that the user will be able to enter values for them. But if we add attributes in a web panel's form, they will have output features, meaning that they will not be able to be edited. Instead, the data stored for those attributes in the database will only be displayed. Let's then define a variable in this web panel. We will create it under the name percentage and define it as a numeric 3 type. We now go back to the form to directly type in it enter percentage. We can change the format of this text. We press enter, and below the text we insert the percentage variable. We select Insert Variable and choose the percentage variable. We now drag a button from the toolbox to the form. We can see that the page is now ready for the user to enter the increase percentage desired, and press the button to execute an automatic process that applies the increase in prices across all flights. So if we double-click the button, we will see that we're taken to the Events section of the web panel, and specifically, the cursor will be positioned inside the event associated with the button, the Enter event. Here we will code the instructions we want to execute when the user presses the button. Let's remember what we should do. Browse all the flights stored, and update the price of each one of them. Let's then write a for each command with its corresponding end for to navigate the flight table. A for each command must always contain at least one attribute in its body for GeneXus to determine the base table to be navigated by the for each. Which attribute could we reference? And how can we update the price for each flight? There's only one way for us to update the database in a web panel, and that is to apply the business component concept. Now let's see what a business component is and how it's used. Since we want to update flight data, we will open the flight transaction to see its properties. We can see that there is a property called business component, and we will set it to true. All transactions include the business component property, so we can set to true the business component property of any transaction in the knowledge base. When we set the business component property of a transaction to true, we will be able to define, in any object of the knowledge base, a variable of the business component type of the transaction defined as such. Using this variable, we'll be able to execute the flight transaction without its form, in order to perform the updates in the database. Also, when we use this variable of the business component type of a transaction, all the rules we have stated in the transaction will be triggered, as well as all the automatic controls offered by the transaction to validate the consistency of the data stored. Let's go back to the object we were coding to learn to use the variables of the business component type. We will write the first instruction inside the for each that we were coding in the Enter Percentage web panel. We type ampersand and select the BC flight variable which we've defined. We now type in a period and select the load method. The load method allows us to load into memory the data corresponding to the primary key value we indicate inside the parentheses. The primary key value included in it must be a valid value for the primary key of the transaction set as a business component. In this case, we're loading a flight into memory, and the primary key value is in the flight ID attribute, because our objective is to navigate the flight table through the for each. And for each flight navigated, we'll have the values of its attributes. Regarding our objective of navigating the flight table, note that this flight ID attribute is, for the time being, the only attribute present in the for each, and that's what makes flight the base table of the for each. So, the for each will navigate the entire flight table, because we have not defined a where clause with filtering conditions, and for each record navigated, the instructions included in the for each will be executed. The first sentence then executes something equivalent to what happens when we type a flight identifier value in the transaction and exit the field. All the data corresponding to that identifier are loaded into memory, and in this case, we will have them available in the BC flight variable. We can modify only the same attribute values that are editable on the transaction's form, that is, those in the base table associated with the transaction, in this case, flight. Now let's go back to the code we were writing. Since the first instruction of the for each loaded the data of the navigated flight into memory, all we need to do now is modify the flight's price and save the changes. Let's write the second instruction inside the for each. We type ampersand, select the BC flight variable, add a period, and we can see that we have two types of elements that we can select. Those with the purple icon are methods to be applied to the variable, such as the load method we have just used and explained. And the ones with the hand icon are the attributes included in the structure of the transaction set as business component, corresponding to the type of the BC flight variable. We now select the flight price attribute, and to assign a value to the attribute, we type the equal sign. To the right of the sign, now we must define the calculation to obtain the new price of the flight, with the increased percentage applied. Let's write the calculation first to then explain it. This instruction assigns to the price we've loaded into memory the same value that it had, multiplied by the result of the calculation shown in parentheses. This calculation adds 1 plus the value of the percentage variable divided by 100. So for instance, if the increased percentage entered in the variable is 20, when we multiply the current price by 1.20, we obtain the new price with a 20% increase, which we then assign to the flight price. We must now physically save this update. Let's write the instruction to do this. BC flight dot, we save, and note that the methods are always followed by parentheses. When the save method is executed, the rules defined in the flight transaction will be triggered, with some exceptions, and the automatic validations done by the transaction will be executed. In the event of errors, either because error rules stated in the transaction have been triggered, or due to automatic validations, the text corresponding to what happened will be loaded into memory in a collection. And we can run through and process this collection. We will not be showing that in this video. It'll be in another video that provides more details on business components. Let's now determine if the saving operation was actually successful. If it was, we'll write commit. If not, we'll write rollback to undo the operations we tried to perform on the database following the last commit. Now we'll try this functionality we've just implemented. We press F5. Then execute the flight transaction to check the price of some flights. And then execute the enter percentage web panel. We now enter a 50% increase and press the confirm button. We have not included any message informing that the process was performed and concluded, but we can verify this by executing the flight transaction again. If we recall the prices we'd entered, we can now see that they are all 50% higher. Now let's go back to our coding. It must be made clear that we can use a variable of the business component type outside a for each command. For example, this entire code is valid outside the for each, with the only exception being that the flight identifier value to be loaded into memory would have to be specified as a fixed value, like this. Or it would have to be loaded in a variable, with the variable specified inside the parentheses like this. This would be an individual load into memory of one flight, and we would be updating the price of that flight. It would not be a massive update like the one we did inside the for each. Now let's suppose that we want to delete the flights we've recorded. To delete something in the database by using business components, we have to do almost the same that we did for updating. We first load into memory the data associated with a primary key using the load method, and then execute the delete method to perform the deletion. With this code, we're navigating the whole flight table. We load each flight navigated into the memory and delete the flight. This last block of code remains the same, validating if no errors occurred in our attempt to delete, in which case we will confirm the database deletion. Otherwise, we will not. Just as we saw in the updating, we might want to delete a specific flight. To do this, we code the load into memory of the specific flight and deletion, outside the for each command. We must now see how to insert a flight by using business components. It's the same as updating, with the only difference that we do not need to perform the load because we will not retrieve a flight, but rather insert a new one. Let's then remove the for each, the N4, and the line with the load method. Regardless of whether it's the enter event of an object or any other context, to insert a record by using the business component concept, we basically need to assign values to the attributes we want, and then execute the save method for the variable. Next, we should execute the commit or rollback, depending on the operation's success or failure, as we've seen. Since the flight ID has the auto number property set to true, we do not need to assign a value to that attribute, just like when we operate with the form of the flight transaction. Also, if we want to assign a specific origin country and city, and a specific destination country and city to the new flight we'll be inserting, we must, as we've done so far, write bcflight dot select flight departure country ID, assign a value, and repeat the operation for each attribute to which we want to load values until we save and commit a rollback. The save method, as we can see, is used to save both the insertion of a new record or to save an update. If we first load a record into memory, assign values, and then save, GeneXus will take it as an update. And if we assign values to the attributes and save, GeneXus understands it as an insertion. We must not forget the commit. We've just seen another way to update the database, specifically using business components. As we've said, If a transaction is defined as a business component, it'll be possible to define a variable of this type in any object in order to update the database from there. We have yet to see one more alternative to update the database with certain commands. It'll be explained in an upcoming video, and we must be aware that it can only be used in procedure objects.